Your phone can talk to the world, but only the part of it connected to the legacy telecom stack. But soon, that same phone will be able to discover, connect to, and exchange encrypted data with a mesh network spanning Bluetooth, LoRa, even over-the-horizon packet radio. No internet required. Together, these otherwise disconnected communication networks become a kind of super mesh, one network of networks that can use whatever path is available. Unlike 5G cellular or fiber internet, the networks we're talking about are free to use and open source. It's the foundation for a parallel internet that no single company owns or controls, something today's telecom stack was never designed to provide. This is Reticulum, an open, cryptographically complete networking stack for building resilient networks over just about any medium that can push ones and zeros. Instead of relying on IP addresses and fixed infrastructure, it uses cryptographic destinations to find a path across whatever links are available, even if they're completely offline. Same permissionless, community-operated spirit as Web3, except without the casino. It's basically the blockchain of communication. That means no monthly subscriptions, no central service sitting in the middle, and privacy by default. And over the past few months, the Reticulum ecosystem has really come alive. New hardware, new apps, and more builders pushing it forward. I don't think people understand how transformative the next era of the internet is going to be. But for Reticulum to live up to the hype and actually be ready for prime time, it can't only work for radio heads willing to assemble elaborate hardware. Everyday people need to be able to use it on devices that they already understand, whether you're at home or deep in the backcountry or somewhere that conventional infrastructure has failed. Joining the network should still begin with a device you already understand, which presents us with one clean challenge. Can my partner Amelia, who has no Reticulum experience, download an app and send a message to an offline LoRa device and receive a reply, even though it has no internet connection? With what I know about Reticulum, I think we can. I've spent the last few years building networks you can actually own and operate without subscriptions, designed to work when conventional infrastructure fails. But each new implementation requires other like devices in order to begin building out that mesh. And as cool as that might be, they're locked to either LoRa or Bluetooth or whatever the radio modulation is. Even within projects like Meshtastic or Meshcore, you have to use the same frequency and parameters to reach other nodes. I recently drove from Florida all the way to New Hampshire and back with a Meshtastic node running in my car, and it was listening on Meshtastic's long, fast channel. So the LoRa frequency was 906, it had a bandwidth of 250 kilohertz, spreading factor of 11, and a coding rate of 4/5. All said and done, I picked up a healthy 458 nodes along my journey, and that proves that the interest, infrastructure, and community already exist at scale. But none of those LoRa connections automatically became one network with other LoRa configurations, Wi-Fi Halo, packet radio, HF, the regular internet, or really anything attempting to do the same thing in another lane. That's when I realized that the infrastructure build-out wasn't the missing piece. The ability to bridge network types was. And that realization brought me to Reticulum. Now, I'll be honest, putting my own public Reticulum transport node on the internet makes me a little nervous. It means exposing a TCP backbone that anyone can connect to and use, or potentially abuse. I've never deliberately opened infrastructure like this to the public before. Building networking infrastructure by the people who use it, for the people who use it, and learning how to do that safely. But getting the node online would only prove that I could build it. It wouldn't prove that everyday people could actually use it on devices they already own. For that, Amelia is a good candidate. She has none of my context and has never used Reticulum. She gets the free app, and once the node is ready, one address. After that, I'm not going to help her. If she can't figure it out, then I haven't built an internet for everyone. I've built another network for experts. This is our map, a live map of the Reticulum network. It shows nodes that choose to make themselves discoverable, where they're located, and what protocols they support. For Amelia to enter Reticulum through Wi-Fi, 5G, or LTE, her app needs the public address of a TCP backbone node. Now, we could use one that already exists, Builders like Dude.eth, the creator of RatSpeak, and Ken, also known as Frosty, who built a mobile Reticulum hotspot, are already pushing this ecosystem in some really interesting directions. But I didn't want this project to only consume what others had built. I wanted to leave the network larger than we found it. So I decided to build a public parallel node hosted on GCP, one Amelia could use for this challenge, but also one anyone could use after this video ends. Now, the irony isn't lost on me that I'm building an open source internet that no one controls on Google Cloud Platform, which is about as centralized as infrastructure gets. But that's the beauty of Reticulum. It can use legacy infrastructure without being permanently tied to it. As LoRa, APRS, HF, and other links fill in the gaps, the network can eventually route around the internet itself. And that's where I truly believe this space is heading. I installed Reticulum and enabled the transport, and I gave the TCP interface an address Amelia could reach. When the daemon started, the server began announcing itself to the wider network. But this was also where I got nervous. I wanted to make sure bad actors couldn't abuse my public node or use it as a way into my servers, since this is now publicly exposed. Years ago, my Google Cloud account was compromised. I woke up to dozens of virtual machines, burning through expensive GPUs and draining my wallet by the minute. So yeah, ask me how I know. Nothing will put the fear of God in you faster than watching a metered service run up a cloud bill tied to your account. And that's where this video's sponsor, TryHackMe, comes in. It's a hands-on, browser-based cybersecurity training platform that lets you safely practice real-world attacks and defenses in a sandboxed environment running in your browser. It helps you understand how hackers think so you can spot problems before they do. You get guided rooms and learning paths, all based on real-world exploits. You also get Echo, your AI tutor, which helps you learn faster. Here I am in the offensive security room where we're essentially simulating hacking into an online bank. Ethically, of course. TryHackMe spins up a virtual machine where I can run a command line tool called GoBuster, which finds hidden pages on the site by brute forcing a word list and checking status codes. And here we go. It found a custom internal transfer page intended only for bankers. And if you want to see if we can make an actual bank transfer on that page, then go ahead and continue the course. And that's how you learn to think like an attacker, by doing. In my opinion, investments along these lines will always pay dividends, particularly in the age of AI. These attacks are becoming increasingly sophisticated. You can even showcase awards and certifications on your LinkedIn profile, helping you level up both personally and professionally. If you want to try this yourself, jump into TryHackMe with the link in the description below. Start with the offensive security room and see how far you get. Many of the rooms are free to play, and if you use my code SLAYER, you'll get 25% off the annual plan if you want full access. And that matters here because this whole project only becomes useful if people can run public pieces of infrastructure without unnecessary risk. Which brings us back to the node. We had the node exposed and working under a public static IP address, but I wanted to give it its own domain. So I created a CNAME on build with parallel called RNS1, pointing to our GCP compute engine instance. We added the static GPS coordinates for the general vicinity where the node is managed, so it would appear on the map where we renamed the node and shut off any additional ports and access it didn't need. Finally, it was ready. And there it is, our public parallel node, live on our map alongside other nodes around the world. Well, I could stop here and call this a successful build, but a dot on a map doesn't prove that anyone can actually use it. We've only built the doorway. We still have to have someone walk through it. Now, in prior videos, we've moved Reticulum data over LoRa, Ethernet, traditional Wi-Fi, even Wi-Fi Halo. In fact, we even sent a message over Tailscale Mesh VPN. But in this video, we want to send messages without requiring any exotic gear from our sender, Amelia. Before handing it to Amelia, I need to prove the node worked from somewhere outside GCP. So on my Mac, I opened CrossTalk, the Reticulum client I've been building. It works in a browser or as a standalone app. I'll put a link to that in the description below. I added rns1.buildwithparallel.com as a TCP interface, entered the port, and enabled it, the same way anyone else would connect to the node. Within seconds, CrossTalk had a path to the network. CrossTalk has one view that I'm going to deliberately not show you quite yet. I recently added it to expose the infrastructure operating underneath the network, but showing it now would give away one of the tests coming later, but I wanted something more visual than a connection indicator. So I opened opened Nomad Network browser and entered the cryptographic address of a tiny page I created. And there it is. This is NomadNet, a lightweight text-based alternative to the web. Instead of living at a conventional website or domain, pages are addressed and delivered directly over Reticulum. Many are privately hosted on tiny, low-powered systems, some even running on solar. So our node wasn't just online and routing traffic, it was already serving a tiny piece of the open source internet. And this is only one small piece of the larger mission. On this channel, our goal is to build a free open source internet that anyone can use, build, and own. But connecting from another computer is still a builder's test. Amelia has to prove this works for a normal person on a normal phone. For that, we're using Columba, which is an Android client for Reticulum. Sideband proved Reticulum could work on Android, but Columba is the first client I've used that begins to feel like a normal messaging app and can connect through TCP, Wi-Fi, Bluetooth, or an R node. In my experience, it has also been considerably more reliable than sideband. That matters because if joining this network requires a terminal tutorial, it will never reach everyday people. I gave Amelia the app and one address, the public node that we just built. From here, she's on her own. Now, the obvious objection is that I've built an alternative internet using Google Cloud, and you'd be right. So far, this is still the regular internet carrying Reticulum traffic, just with extra steps. Today, the conventional internet is carrying the long-haul portion, but to Reticulum, even the internet is only another temporary interface. The real test is whether that message can leave conventional infrastructure and reach a device that has no internet connection at all. To get a message from Amelia to a phone with no internet, I needed 3 pieces working together. First, Amelia's phone. She's using Columba over LTE, connected by TCP to the public node we just built on GCP. Second, the field bridge. This is Haven connected to Starlink and a USB R node. Haven is running Reticulum with 2 interfaces, a TCP connection to our public node through Starlink and a 915 MHz LoRa connection through the R node. That means traffic can arrive from the internet on one side and leave over LoRa on the other. Third, the offline phone. This is a backup Android phone running Columba with cellular Wi-Fi and Bluetooth disabled. Its only connection is the R node attached over USB, and its only path to the network is LoRa. If everything works, that route should carry a message in both directions. Okay, so Amelia is back at the house with her Android phone, and she's gonna just try sending us messages. We're gonna try sending messages to her. Her Android phone is connected to the internet. The internet is connected to our Starlink. Our Starlink is connected to our Heltec V4 way over there. But then from there, the internet drops off, and it's just LoRa. So that is the mission here. And experiments like this are exactly why I like Haven. Underneath, it's a Raspberry Pi running Linux, so I can connect SDRs, microcontrollers, LoRa boards, and whatever strange peripheral the next experiment requires. Unlike most closed all-in-one wireless systems, Haven provides its own power, USB connectivity, and a full field computer that I can mount on a tripod. I'm just gonna test to see if I can send a message and get it through, because now that the node's up, that might just work. I'm gonna do test 2, see what happens. It's not up. The Heltec is up, so the routing just hasn't established yet. 2 checks. I do, we're looking good. So what this will let me do is put the Android phone up there, and then also the antenna is going to be that guy. So just a little bit better of a setup here. So now I just want to drive out and see how far we can go and still get messages through. So that's our goal right now. Okay, so we're at half a mile here, so I think it's a good time to run a little test, radio check test. So I'm just gonna do T2. It says last seen 8 minutes ago. It's not a good sign. Oh, last seen just now. So I think we're still good. That's half a mile, so we're gonna keep going here. No cellular connection, no Wi-Fi. The only possible path between us is LoRa. So 2 check boxes this time. We are 0.84 miles away. So we're gonna keep going until the signal dies there. But all right, so we're at 2.3 miles. I wanna see if I can get anything through here, but I doubt it, because we have a whole lot of foliage, quite a few obstacles, or obstructions rather. So I don't expect this to go through. Okay, we're about 2.5 miles away from the base station, and we have no connection. So now you get to see what I was hiding. This is Old Faithful. We're officially infrastructure maxing, and the node attached to it doesn't need a phone, a Raspberry Pi, or even a full operating system. Earlier, I flashed another Heltec V4 with a special new firmware called RT Node. A builder who goes by JRL290 on GitHub packaged micro Reticulum into a usable standalone transport node for this board. Okay, so what I came up with here is I basically implemented like a version of micro Reticulum, which is an entire RNS stack running just on an MCU. And this guy's set up to act as just a relay. So it's not an identity, but it can broaden the mesh and support the mesh. It doesn't need a full-fledged computer, just runs on the MCU. This wasn't possible even just like a couple months ago. But because there's so much innovation in the space, I was able to get this to work. So what I'm gonna do is I'm gonna take this, I'm gonna throw it on the drone, and then maybe my car could relay messages through this back to our original base station. This is what makes this different from the two ground R nodes. Those act as LoRa radios for a phone or a computer, but this actually runs Reticulum itself. And remember the part of CrossTalk I refused to show you? Most Reticulum clients focus on LXMF delivery addresses, the people and services you can actually message. But some nodes don't have an LXMF delivery address at all. They aren't contacts. They exist only to discover paths and relay traffic. I added a feature to CrossTalk that exposes those infrastructure nodes too. And there it is, the Heltec V4 transport node, Old Faithful. CrossTalk can see it even though it has no messaging address, because its only job is to act as a relay infrastructure. The US military helped pioneer packet networking. I improved it by attaching a $20 transport node to a drone. You're welcome. And I haven't seen anyone do this with Reticulum yet, so this might be a first. Up until recently, this kind of self-contained drone relay was something I had only seen Meshtastic do. But now with micro Reticulum, we can run full self-contained nodes on microcontrollers. That means drone nodes like SkyMesh here, along with other solar-powered and exotic self-contained off-grid infrastructure, which is super exciting stuff. The Heltec drone adapter fits the Heltec V3 and V4 and can be purchased on the website. I just love cheap rigs that punch outside their weight class, and this is definitely an example of that. I configured it as a standalone transport node, a LoRa-only repeater. It isn't a messaging contact. Its only job is to discover paths and relay traffic. It uses the same LoRa parameters as both ground radios. And because LoRa depends heavily on line of sight, lifting this above the trees could be sufficient to extend our LoRa path back to our base station. At least that's the theory. If it works, the offline phone should regain a path without us changing anything else at all. The Old Faithful here has to get airborne. But before that could even happen, the drone started overheating. Lovely. So I turned the car's AC all the way up and improvised a cooling station. Bruno may have been overheating too, or maybe he just likes being blasted with cool air. Our ground path was dead. The base station was draining its Life PO4 battery, and now the only thing capable of completing the route couldn't get off the ground. A few minutes later, the warning disappeared, so I went ahead and launched before the drone could find another reason to ruin the experiment. But the problems weren't over. I literally got a vulture trying to take out my drone right now. You guys have no idea. A vulture started circling it, and I've done enough field tests to know it wasn't just admiring the technology. Vulture seems to be gone, hopefully. With Old Faithful finally above the trees, I went back to my Android phone and started testing. Okay, we have our drone up there. I'm flying it right here, but it still says 6 minutes ago, so it hasn't relayed anything yet. So I'm gonna go a bit higher and I'm gonna do an announce and see if that helps at all. The micro Reticulum relay was working, then Reticulum should be able to discover a path through the drone back to Amelia. So I started firing off some messages, and at first it was just crickets. So you can see right here, we tried sending some messages, but mostly not getting any checks. I guess we might not get 2 checks because we're not going to be reading them on the other side. But after quite a bit of back and forth, there it was, a message from Amelia, delivered to our Android phone with no internet connection. Super pumped with that result. So we got some messages through. So that is from Amelia. But I guess if you really think about it, the R node did have an internet connection since it eventually routed to a node with an internet on-ramp. So yeah, this LoRa node has internet, which is crazy. It crossed LoRa to the drone, was repeated to the R node beside Haven, then traveled through the Starlink and our public GCP node before reaching Amelia over LTE. Perhaps the most over-engineered text message in history, but I'm okay with that. Her message crossed the conventional internet, passed through our field bridge, left the internet entirely, and traveled over LoRa, through the airborne relay to the offline phone in my hand. One phone was on LTE and the other was completely offline. Between them, Reticulum stitched the public internet, Starlink, and LoRa into a single encrypted path, a network of networks that were never designed to work together, the next era of communication. The number one question I get is, how do I even get started in this space? So I built a course called the Parallel Primer that gives you all my hard-won insights, the hardware, the software, how the different radios work together, and how to get your first node up and running as fast as possible. I actually build a solar node from beginning to end, and I walk you through the entire stack, front to back, and get you capable enough to build your own infrastructure. The link to that is in the description below. In this test, the legacy internet still carried the middle of the journey. LoRa solved the edge, and elevation gave it reach. But scaling this approach would require many more elevated relays, or alternatively, putting some of them in orbit. But those are pricey propositions. I called cell tower leasing companies, and for that, you're looking at a $3,000 installation fee, a minimum 3-year commitment, and monthly rent. A CubeSat could bypass the towers, but even a bare bones attempt pushes into 5 figures. And I've been turning that problem over in my head for nearly a year now. But I think I've finally found another way to bridge the distance.
This is Kilo Romeo 4 November Papa Field Test 1. HS Gateway 1 online. Target path 200 miles. Internet relays 0. Standing by for Gateway 2. Initiating long haul transport test. Bridging Reticulum.
For more, click here.